Hi, this lesson's from page 471 in your student book, and it truly builds on yesterday's lesson about being able to find a missing measurement by creating a ratio of information you already know. So an indirect measurement allows you to use properties of similar polygons to find the distance or a length that would be difficult to measure directly. So, for example, if you were trying to measure how tall a skyscraper is, and if you had the area around it, you could measure its shadow and then create a ratio from something smaller and its shadow. So, the first one. How tall is a light pole if its shadow is 26 feet and the bench beside it is 2.5 feet tall and a 5-foot shadow? So take the parts from the word problem and you would know that the bench is only 2.5 feet tall with a shadow that's 5 feet tall. And you would have to take that information from the word problem. Then what they're asking is, how tall is the light pole if its shadow is 26 feet long? So create a ratio. The lengths of the shadow is 5 to 26. And then because we started with a smaller object, its height would be in the numerator of the other ratio and set it equal to the unknown value x. And then we would just crisscross multiply. And we would get 5x equals 65. Solve for x. And the light pole, it would be 13 feet. Similarly, how tall is a telephone pole if its shadow is 12.3 meters and a 2-meter sign? So see how the street sign is 2 meters tall, but creates its shadow 3 meters long. So take the information from the word problem and draw a picture, and then create your ratio. X is to 2 as 12.3 is to 3. Crisscross multiply and solve for x. And so we would say the telephone pole is 8.2 meters tall. All right, I think this one's kind of fun. We're actually creating ratios, and notice that there's a small triangle inside a large triangle. So when we create a ratio here to find the missing value for D, you would say the leg of the right triangle D, well, actually, in this example, we start with the small one. So the leg of the small triangle 40, and set that as a ratio to the larger triangle. So 40 is to D, and then go back to the smaller triangle, as 320 is to the whole length of the hypotenuse of the larger triangle, 482. So look, compare where we got the values, and we did small is to large as small is to large. And then just finish it by crisscross multiplying. 320D equals 19,280. Divide both sides by 320, and you would get D equals 60.25 meters. And that's it for our video tonight. So we're just building on yesterday's lesson. Hope that helped, and I look forward to seeing you tomorrow. Great job.